Here is a circle with a radius of r and a central angle theta that cuts off an arc of length s. Now, area A stands for the area of this sector right here. Here's the formulas I have if theta is written in radians. The radian measure for theta, as you know, is the arc length s divided by the radius r. That means that the arc length s is going to be r times theta as long as theta is written in radians. So if I multiply both sides of this by r, I get r times theta is equal to s. So here's a formula that allows us to find arc length if we're given the radius and the central angle measure in radians. The area of that sector is 1/2 r squared times theta, and again, theta has to be measured in radians. So we want to work with these formulas right here. The new one is really an old formula written a new way for arc length, and then area of a sector, that's a new formula. Let's go to the board and work our first problem. Suppose that theta equals 60 degrees as a central angle in a circle with a radius of 4 millimeters. Let's find the arc length s cut off by angle theta. So let me draw a little picture over here. This will be my circle. I'll have a central angle that will be 60 degrees. The radius of this circle is 4, so that's 4 and that's 4, and what I want to find is this arc length s. Well, I know my formula for arc length tells me that s is equal to r times theta as long as theta is written in radians. So let's put in r, that's 4 millimeters, times theta, which is 60 degrees, and then I'll just convert 60 degrees into radians by multiplying by pi over 180 degrees. So what I end up with here, let's see, I'll divide 60 into 180, that goes 3 times, 4 pi over 3, and the units will be millimeters, and then I can convert that into a decimal using my calculator, and that will come out 4.19 millimeters, or that's approximately, I should say, 4.19 millimeters to the nearest hundredth. So 4.19 millimeters or 4 pi over 3 millimeters. In either case, that's the length of this arc S that's cut off by a central angle of 60 degrees in a circle that has a radius of 4. Here's our next problem. Theta is equal to pi over 4 this time, so it's given in radians. S is equal to pi centimeters. Let's find r. So remember, theta is a central angle in a circle that has a radius of r, and then theta cuts off an arc of length pi. So let's draw a little picture right here. Theta will be equal to pi over 4, so I'll just draw this angle in here, and this is pi over 4. And I have, I'm looking for r, that's the radius of the circle, and I'm given s is pi centimeters right there. Well, let's use our formula for arc length. Arc length is s is equal to r times theta. So I have s, it's pi. I'm looking for r, and I have theta, which is pi over 4. So I'll multiply both sides of this equation by 4 over pi. So let's do that. 4 over pi, 4 over pi. When I multiply, the pi's divide out over here, and I end up with r is equal to 4, because these all divide out on this side. So r is equal to 4, and let's see, what are the units on this? Centimeters. So if I have a circle in which a central angle of pi over 4 radians, which would be 45 degrees, cuts off an arc of length pi right here, then the radius of that circle has to be 4 centimeters. So if I cut off a arc of pi centimeters, then the radius is going to end up to be 4 centimeters if that central angle is pi over 4 radians. Let's look at a problem now that has to do with a clock. Suppose the minute hand on the clock is 2.4 centimeters. Okay, how far does the tip travel in 20 minutes? So let's suppose here that I have the minute hand of a clock. Suppose it starts right there and then travels and then goes for 20 minutes. So from here to here it takes 20 minutes. Let me see if I can get this right here. And suppose that this is 2.4 centimeters. Well, we can think of this as being a central angle in a circle of radius 2.4, and so what I want to know is the distance that the tip of the minute hand travels. So I want to know, what is this arc length right here, arc length s? Well, I need to find this angle theta, so let's see. Theta is equal to, well, this is 20 minutes. Once around would be 60 minutes, so 20/60th times 2 pi. I know once around the circle will be 2 pi radians for this angle right here, and so I'm going 20/60ths of that, so I'll have 20/60ths times 2 pi. That will be my angle theta, and theta will be in radians. So s, the distance it travels, is r times theta, r is equal to 2.4 times 20 over 60 times 2 pi. And let's see, I can divide out these tens here, so I get 2/6 times 2 is 4. I'm going to have to write down here, so 2.4 times 2 times 2 is 4/6, so 2 pi over 3. This is multiplication right here. I better write it like this. Let's see, I'm going to try to divide this 3 into 2.4. 3 into 2.4 is going to go 0.8 times. Let's see, so 0.8 times 2, okay, how about 1.6 pi as the exact value of the distance that's traveled, and what have I got here? Centimeters. So 1.6 pi centimeters, or if I want to multiply 1.6 times pi, let's see what I have here. That comes out to be 5.03 centimeters. So I should say approximately equal to 5.03 centimeters. So if you have a clock and the minute hand of the clock is 2.4 centimeters long, then in 20 minutes, the tip of that minute hand must travel about 5.03 centimeters. And it looks about like that's what it should be. If that's 2.4, that looks like it's going to be a little more than twice that long in 20 minutes. Let's look at our next problem. Here we have theta is 15 degrees, r is equal to 5 meters. Let's find the area of the sector formed by theta and the circle. So to draw a little picture over here, here's my circle. Theta is equal to 15 degrees, so that's this angle right here, 15 degrees. And r is equal to 5, so that's 5 and that's 5. What I want to find is the area of this sector, the area of this little piece of pie right here that I have. So my formula for that is A is equal to 1/2 r squared times theta. So A is equal to 1/2 r squared times theta, and theta must be in radians. I have 15 degrees for theta. I'll convert to radians as I go. So I have 1/2 times 5 squared times 15 degrees times pi over 180 to convert from degrees into radians. So this is what the setup looks like. Now let's see, I have 25 times 15 times pi over 2 times 180. Let's just see what this is. 25 times 15 times pi over 2 times 180. 15 will divide into 180 12 times. So let's say I have 25 pi divided by 2 times 12 is 24. So 25 pi over 24, and my units were meters, so this is going to be square meters, and that will come from right here where I have 5 meters. Quantity squared is 25 meters squared. So I'll put in the units there. That is the exact value of the area of that sector, and let's see, if I want to write this as a decimal, it comes out 3.27 meters squared. Now, does that seem to make sense? This is 3.14 times about 1, so yeah, 3.27 square meters. So if I have a central angle in a circle, it measures 15 degrees, the radius is 5, then the area of that sector that it cuts off by this formula, 1/2 r squared theta, is approximately 3.27 square